part 2, solution to problem 2. In part 1, I show you how to draw the AOA diagram for this problem, and I suggested that you draw by yourself before you watch that video. And again, now you should pause this video and calculate early and late event time, identify critical path and critical activity by your own. So with that one, if you're done, you can check this lesson video. So with that, we can plug in the number just like we did in here with the duration and find out early event time and late event time like problem 1. So here, the duration for activity A, you have that is 7 days. Activity B, 5 days. Activity C, 23. D, 5. Activity E, 20. Activity G, this is activity F, 15. Activity G, 7. Activity H, 10. I, 3. And J, 5. So with that, we can divide by 3 to determine early event time and late event time. What is early event time and late event time? You can see the definition in the previous lesson video or the PowerPoint slide that you have. And now we can identify the node. So start with 1 from left to right. So we have 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 nodes in here. So let's go with the first on way with the forward. So from left to right. And forward, if you recall the node here, early event to find early event time and addition maximum. Backward from right to left, find late event time and subtraction and minimum. So with that one, we can do it in here. So forward start at 0 at the first node, and onway have 1 node at the beginning for the whole project, 1 node at the end for the whole project. In this case, you have node 1, the beginning only 1, and node 10 is for the end node for the whole project. So from here, forward addition and maximum. So you have that one is 0 plus 5 for B. So node here will be 5. And then for node number 2, the early event time for 2, then because there are 2 arrows get in node 2, that is A and B apostrophe. So you can make a phantom number 0 plus 7, so that is 7. And then 5 plus 0, dummy activity have no time and resources, so it will be 5. So in maximum, so you get that 5 in here. And then you have 5 for C, 5 to node 4, 5 plus 23, you will have, this should be maximum 7. Maximum, forward maximum, 5 and 7, maximum 7. And for node 4, you have 7, 2, addition, 23, duration of C, so you will have 30. And then similarly, you have 30 plus 5, you have 35. And for the node number 6, you have 2 arrows get in number 6, the activity E and the D apostrophe. So we need to get the maximum in these scenarios. So we have, go to 3 to 6, 5 plus 20, you have here the phantom number 25. 25. And then you have 35 plus D apostrophe 0, dummy, so you have 35. So maximum 25, 35, so you get that is 35. 35. Similarly, 7, node 7, you have 2 arrow get in, so 35 plus 7, you will have 42. 42, because 2 arrows, so we can make that here. And then 35 from node 6 to node or event 7, so 35 plus duration of f 15, so you have 50. And get the maximum, 42 and 50, so you will have 50 maximum. And now 50 plus 10 for h, 60, 60 plus 3, 63, 63 for 5, so you have 68. 68. So that's 68 days to complete this project. And now we go to backward. That start from right to left. And subtraction and minimum. The first is always move that number to here. So it will be 68. 68. If you have multiple end nodes, I suggest not. You only have to close at one single end node for the whole activity. If you have multiple, get the maximum duration, in this case 68, and put all the late event time on the end nodes of the project is 68, as I mentioned in the problem 1. So backward subtraction and minimum. So you have 68, the green one, minus 5 for j, duration of j. So we'll get 63. 63 minus 3, so you have 60. 60 minus 10, it will be 50. Now, what we do? We need to go to node 5 and node 6. Let's go to node 6 first. Only one arrow go out node 6. So you have 50 minus 15. So it's only one. Then you don't need to get the minimum. 50 minus 15, you have 35. And there 2 arrows go out node 5. So you have to get the minimum. 50 minus duration for G, 7. So you have 43. 43. And then you have 6 to 5. You have 35 minus D apostrophe 0. So you have 35. And that's 35 and 43. You get the minimum. So it will be 35 backward minimum. 35 minus 5, 30. Okay, and then you go to number here. You have go ahead to find out the node for 2, 3, and 1. So which one we go to C, and as you can see, now we can go C to 4 to 2. Node 4 is 30 green minus 23, so you have 7. 30 minus 23, 7. And then you have 2 arrows go out of node 3. The first one is 6 back to 3, so 35 minus 20, so you have that in minimum here is the 35 minus 20, 15. 15. Phantom. And then we have 7, 2 to 3. 7 minus 0, B apostrophe. So you have 7. And minimum between 7 and 15. So you will have 7. And then go to node 1. For node 2 to 1, back to 1. 7. Green minus duration 7, so you have 0. And then 7 minus 5, you had 2. And get the minimum, it will be 0. And that you good when you have the same start node for the project, same early event time and late event time. For the finish node, the end node for the whole project, node 10 in here, early event time 68 days, late event time 68 days. And that you good for the calculation early and late event time. And now we need to determine the critical path and critical activity. By definition, critical path through the node or event with early event time equal to late event time. So with that one, we can have node here 1 to 2, early event time equal to late event time. And then you have 2 to 4, early event time, late event time. And then go through D, and then not G, but it D apostrophe, and you can see that where the node number 6, early event time equal late event time. And then we have F, and then H, I, G. So those are the critical path and critical activity. So let's put one here. We can say that project duration (68 days), and then we have critical path that we can see that the A, go through A, and then C, D, F, H, I, and J. And then we also have critical activity and that is the activity on critical path, that it will be A, C, D, F, H, I, and J. And only one path in this case, but for the project, they can have multiple critical paths. Can be have 1, 2, 3, etc. In this problem, you only have one critical path and go through 7 activity as shown in here. And the project needs 68 days to complete.